Hello everyone, welcome back to all of you on my YouTube channel. I'm Ankit Misra. I'm teaching for Gate Chemical Engineers for since last 5 years. So I have started this lecture series of process transmission control, and this one is the fourth lecture of process transmission control for Gate 2026. As well as this lecture will be very much helpful for the ONGC as well as BARC examination, and also I'm making this video for keeping BPSC assistant in the year 2025 examination. So those who are watching this video, definitely they are going to get a huge benefit of you know solving problem in all of these examinations from this particular topic. Okay, so without wasting our time, I'll be starting with today's lecture. So here you'll see in the previous lecture I have started solving this kind of problem where I was solving problem based on the Laplace inverse and how we can do the Laplace inverse for all of these kind of function, where I have taken the partial fraction, and based on the partial fraction you can calculate the coefficient, and once you calculated the coefficient you can calculate the Laplace inverse, because I have already discussed the formula of all of these things, right? And after that I have started solving the problem based on the graph, that let's say if you have given a unit step input and how you can plot this kind of thing, and based on this you can calculate. And after that also I have started discussion about if two step function is written in the combination of linear combination of if a function has been written in linear combination of two step function, then how we can make the plot of these kind of things, right? So this was one topic. Now I have told you the questions can be asked in vice versa. They will give you function, they will ask you which of the following plots are correct, and they will give you the plot and you are supposed to write the function. So let's try to understand today that how we can write a function if plot have been given to you. So let's say we have this kind of function today. Okay, so let's say this one is your ft and this one is t, right? So if I plot this thing something like that, right? And let's say if this value t is equals to, if I'm assuming is 4, and let's say this value is 2, right? So what will be the function? So the function can be written as what I have told you. Here you can see the magnitude is 2, so first I'll write magnitude, and this is a step function, so u, and obviously t, and when t is less than 4, the step functional value is 0, and when t is greater than 4 it is acquiring the value 2, so that will be equals to t minus 4, right? So this one will be your correct answer of the function that you want to write. Okay, this is one part. Now there may be another question that you can solve here like that. So let's try to solve another problem here in the next page. So here you can see, so the function, the plot of the function looks like in this way. So if this is your ft and this is t, is that clear? And if a function is like that, something like that, okay? And if I am assuming if this value is given to you is 2, and if this value is also 4, and if this is let's say 4 and here it is 6, then how can you write? So the functional value or ft can be written as, first I'll go to 4, and the magnitude of a step input is 2, so I can write 2u t minus 4, and again there is a step input of plus 2 here, right? Magnitude, so this is plus 2 and this is plus 2, so that is plus 2u again t minus 6. Why? Because there is a 6, something like that. Okay, so this is how you can write these things. Sorry, here it will be plus 4. Why? Because total step magnitude is 4, right? That is 4. Is that clear? So this will be your correct answer for this particular problem. So similarly, if you will solve the problem in Kafner book, then definitely you will be getting lots of problem based on this kind of function, and you can solve. So let's try to solve one more problem where you will see this kind of thing. Okay, let's solve this kind of problem first. So let's say if you have a function like that, and after that this looks like that, right? So this one is ft and this one is t, right? So if this function looks like this way, so then how can you write these things? Let's say if this value is your 2 here and this one is 1, so here this one is ramp function, and if ramp function is there, this should go like that, right? But this is not going in that way, so this is taking a turn like that, and again with the negative slope of that much. And if there is slope here, is if I'm assuming slope is m, so here slope is minus m, and after that it is coming like that and it is going like that. Is that clear? Something like that. So how can we write this function? Just try to understand this thing. So whenever you want to write this function can be written as ft is equals to obviously slope multiplied with, that is t minus 0, and multiplied with u t minus 0. Is that clear? So this is how ramp function can be written as. But here in this particular problem, you see slope is how much? Slope is 2 divided by 1 is 2. So what is ft for this particular problem? That is 2 into t is 1 here. So u t minus 1, and obviously into t minus 0. Sorry, here at t equals to 0, no? Yeah. So at t equals to 0, there is ramp input, right? And now it should go like that, but again you are taking a you are giving a negative ramp input of magnitude minus m. So now you can write minus 2 into u t minus 1 at t equals to 1 into what? T minus 1. So this will be your correct answer for the ramp input kind of function. Is that clear? So let's try to understand one more problem here that will clear most of the concept that is associated with particular topic. So let's say we have this kind of function. So if it is your, let's say ft versus t, and it goes like that. Is that clear? And if I am assuming this t is equals to 4, this value is 1, and here t is equals to 1. So what you see here, what is slope here? Slope of this line can be written as slope is equals to y by x, that is equals to 1 by 4. That is the magnitude of the slope. And at what time it is acquiring a ramp input? That is at t equals to 1. So before this there is a 0 magnitude, so you don't have to write. So the functional value ft can be written as what? So that is slope is 1 by 4, and obviously multiplied with what at time t equals to 1, so t minus 1, and u t minus 1. So it is going like that. So this is how this function can be written as. Is that clear? So this is very simple, but only you have to understand how this is going, and after that you can calculate this thing. So let's say sometimes you can they will give you this kind of problem also, some more complicated, where there is a combination of your step input and the ramp input, and there you will see how these things look like. So let's say it is going like that, then it is going like that, again it is going like that, going like that, and then going like that, something like that. Okay, so here I'll extend this line up to here. So this one is your ft versus time, something like that. So this is a bit more complicated. So let's say this is t equals to 1, let's say this is t equals to 2, t equals to 3. So let's say if I'm assuming this is 2, this value is 4. So first you will see there is a step input up to this, and again there is a magnitude of 2 step input at here, and it is going like that. Okay, so first how can you write this thing? So the value of ft can be written as, and what is the slope here? Let's say at this point, let's say here this is 4 and this is given as 6. So what is slope here? If I'll calculate, slope will be equals to that is 2 divided by how much? This 1, that is equals to 2. Is that clear? So the functional value, if you want to write, so you can write that 2 u t minus 1 plus, again at this point only, how much magnitude is there total? 2. So again you are giving a step input of 2 magnitude, 2 ut minus 2 plus, it should be going like that, but again you have given a magnitude ramp input here having slope 2. So now you can write 2 t minus 3 u t minus 3. Is that clear? So this is how this function can be written. But let's say if this function is given to you, then directly you can plot this kind of curve. So both kind of problem can be asked in your examination. Now based on what kind of problem they have asked, you are supposed to write these things. Is that clear? Okay, now I'll be going to understand, let you understand what is the transfer function and how can you write the transfer function for a process. So let's try to understand the transfer function. Already I have described these things, but again I'll be talking some more thing here. Okay, so here there will be input and there will be output. So obviously there will be input of any process and there will be output based on that input, and this one is the process, right? So the transfer function of any particular process can be written as S domain of output divided by S domain of output divided by S domain of input, this thing. Is that clear? So now how can you calculate the S domain? The S domain can be calculated using the Laplace transform. So if it is if you have been given T domain, then you can directly convert T domain to S domain while you be taking the Laplace, and based on that you can calculate the S domain of the function and you can calculate the output by input, right? So basically what is happening when I am talking about the process dynamics and control in our chemical engineering topic, so you will be having a process, right? So here I have already described there will be a process, and the input that I will be denoting here is xs, which is in S domain, and the output that I will be denoting, which is in ys. So the transfer function of this particular process can be written as ys divided by xs. And let's say the transfer function of this process I can write gps, right? So whenever I am writing the transfer function of process, I'll be denoting it with the help of gps, where gp is in the S domain, means Laplace transform of t domain. So I can directly write the transfer function of any process gps can be written as output in S domain divided by input in S domain. Is that clear? I hope till now this is clear. This is very important concept. Now from here onwards you will see all of this concept that is coming in subsequent topic, that will be based on this, right? So now sometimes if it is written gp of s, that can never be equals to transfer function of output in y domain by transfer function of output in x domain. No, that is not the case. This is completely wrong, right? So this is wrong. Is that clear? So these things you have to understand. Okay, now so here this is input and this is output. So if I want to write what is output ys can be written as gps, the process transfer function multiplied with xs, or I'll make a dot here so that it will be very easy for you, right? So this is your S domain of output function. Is that clear? Okay, now in our GATE syllabus lots of different kind of transfer functions are there that we will see in subsequent lecture, but here let's say if I let you understand the very fundamental thing that we are going to study here is the transfer function So what kind of transfer function that we are going to study here in a simple way, if I want to write this, right? So the first can be written as first order process transfer function. Here second can be written as second order, and obviously there can be nth order. So these many types of process can be there, where we will be studying about the transfer function of all of these process and how can we drive the transfer function for all of these process in this particular topic one by one. Okay, so let's first I'll start with the transfer function for the first order process. Right. So when we talk about the first order process, let's say the transfer function for first order process, that is GPS, that can be written as Kp divided by tau s plus 1, right, where Kp is called as the process gain and tau is called as the time constant. Is that clear? This is how this transfer function look like. Second, if I am talking about second order process, so the second order process can be written as in two way. So first, let's say if I want to write GP as, that can be written as Kp divided by obviously tau square s square plus 2 zeta tau s plus 1. All of these things I'll let you know. And another way this can be written as in another way this can be written as obviously GPS, that can be written as Kp divided by tau 1 s plus 1 into tau 2 s plus 1. So why we are talking in this in first order second order? So see, right now only I'll tell you why I am talking. So in the denominator you will see there is a first linear equation in terms of tau s, that's why this is first order. But in the second order process you will see there is a quadratic equation in terms of s for the denominator, that's why this is called as the second order process. And here you can see this is also a second order, and here it is also a second order thing, right? Now, so first order and second orders process are very important for your GATE examination. So first I'll start with the first order process transfer function and with some different kind of input. So first I'll be talking here first order process with a step input. So obviously I have told you what is xs. Here xs is equals to m divided by s, where m is magnitude of a step input. If you recall my previous lecture, there I have discussed about all of these input: step input, ramp input, sinusoidal input and impulse input, right? So this one is the input, right? xs is the input that already I have described. And if I am talking about first order transfer function GPS, that will be equals to your ys divided by xs, and that used to be equals to Kp divided by tau s plus 1. And here you have seen that xs is m by s. So now I can write these things: ys that will be equals to m divided by s into obviously Kp divided by tau s plus 1. So now if I want to convert this in terms of t domain, so s domain is getting converted into t domain, right? So I'll be taking inverse Laplace transform both side. If I'll take inverse Laplace transform both sides, so I can write Laplace inverse of ys, that can be written as Laplace inverse of m divided by s into kp up into tau s plus 1, right? So Laplace inverse of ys can be written as yt minus ys, that can be written as Laplace inverse of m divided by s into kp divided by tau s plus 1. So if I am talking about this part here, so in a previous lecture I have told you, you have to break this kind of thing in the partial fraction, and then you can calculate the value of coefficient, and after that you will calculate the Laplace inverse. So if I want to write m divided by s into kp divided by tau s plus 1, so that can be written as a divided by s plus b upon tau s plus 1. So that can be written as a into tau s plus 1 plus bs divided by s into tau s plus 1. So here it can be written as mkp divided by s into tau s plus 1. So this is just a simple partial fraction that you would have done in class 12th standard only. So now we can compare the coefficient both side, right? So if I want to compare the coefficient from left hand side and RHS side, so the value of a that you will be getting from here, that will be equals to your mkp. Is that clear? And from here you can say a tau plus b will be equals to 0. So now a you have got mkp tau plus b will be equals to 0. So the value of b can be written as minus of mkp tau. Is that clear? Minus of mkp into tau. Okay, I hope this is clear to all of you. Now if I take Laplace inverse of yt minus ys, that can be written as Laplace inverse of a. A is how much? Mkp divided by s, and plus Laplace inverse of mkp tau divided by tau s plus 1. Is that clear? So now I can write yt minus ys, that can be written as, what is Laplace inverse of mkp by s? So that will be equals to mkp. Is that clear? Plus, if I want to take Laplace inverse, so that can be written as obviously mkp upon s plus 1 upon tau. So what is Laplace inverse of s plus 1 by tau? E to the power minus t by tau. So now it can be written as obviously yt minus ys, that is equals to mkp, and obviously here there was a minus negative sign, so this negative sign will be here, and now I can directly write minus mkp. Is that clear? Into e to the power minus t by tau. So now the value of yt minus ys can be written as, if I take mkp common, so it can be written as 1 minus e to the power minus t by tau. So this is the output response of first order process with a step input, right? So now you can calculate at any particular time what is the output response if value of step input m is given to, magnitude of a step input m is given to you, kp is given to you, and tau is given to you, right? So here if I want to calculate, so this ys is called as the initial steady state value, right? So there will be some value. If ys is 0, let's say if ys is 0, then directly you can write yt can be written as directly mkp into 1 minus e to the power minus t by tau. Is that clear? So this will be your equation. So if you want to plot this kind of equation, so how you can plot? So first I'll be using, this one is my equation first and this one is my equation second. First I'll plot equation first, so you will be having this kind of plot. So here let's say this will be yt and t, and it will start from here only ys, and it will go, and t tending to infinity, the value will be equals to mkp, right? So this will be mkp. So this is a constant value, it will go like that something. But this is for equation first. Now if I want to plot for equation second, so this will look like in this way, because the initial steady state value is 0. So this will be your yt and t, but it will start from here and it will go like that, and finally you can get this value is your mkp. Is that clear? So this is how we can plot the output response of a first order process with a step input having magnitude of a step input is m, and kp is the process gain where tau is the time constant of the process. And now you can calculate the value of output response at any particular time here. So these kind of questions is being asked in the gate examination. Most probably you will see the question is coming from this particular topic, but they will give you some kind of a statement for a particular process. There from there you will understand, okay, this is the first order process and they are saying about the step input, and from there you can calculate this kind of thing. Okay, so I'll stop this lecture up to here only, and I hope I have tried my best to let you understand first this kind of graphical question, and from graph how can make your linear combination of 2 step or 3 step input, and again linear combination of a step and ramp input, something like that. And after that I have started discussion about the transfer function, where I have discussed about what is the transfer function, which is the s domain of output divided by input, and from there I have started different kind of transfer function of different process, that is first order process, second order process, and nth order process. And here I have started discussing about the first order process with a step input, and there you can see we have got this kind of exponential curve, and you can plot this kind of thing. Okay, in the next lecture we'll be solving some numerical on this particular topic, and after that we'll move towards some different kind of input for the first order process, like ramp input as well as the impulse input. Okay, so before stopping my lecture, first I would like to request to all of you that those who have not subscribed my channel, please do like and subscribe the channel first, and also don't forget to press the bell icon, so that if I'm putting any new and important video for your gate examination or for any kind of notification, you will eventually get the notification at your YouTube channel. Okay, thank you, see you in the next lecture.